Hi everybody. Let's talk about congruent triangles. This is the review I used last year. The year before that, I believe it was a test for about congruent triangles. It's more than we're going to deal with this year. I know your test this year will be, your quizzes this year will be short and about a one-page thing. But take a look at this. I think these are great questions. Begins talking about congruent triangles, and it says triangle ABC is congruent to triangle XYZ, and asks me, who's AC congruent to? And you know, because AC, first and third position, that would have to be congruent with segment XZ. So we'll start off with something easy like that, but then it talks about a pair of congruent angles. An angle BCA, second, third, first, would match with angle YZX. Angle YZX. Historically, kids miss this question all the time. I don't know why. Also, the segment from A to the midpoint of BC would be congruent to which segment in the other triangle? And you have to think from A to the midpoint of BC would be congruent to a segment from X to the midpoint of YZ. The segment from X to the midpoint of YZ. I made a little sketch about that. I think it's going to make it kind of more obvious. So if you visualize a couple of triangles, and I say the segment from A to the midpoint of BC, that would have looked like this, probably. Should have used a ruler, I agree. And if these are the congruent triangles, who would match up with this one? Well, I guess I'm going to call that midpoint M, I think. It would have to be congruent with this one, from X to the midpoint of ZY. I'm going to call that M sub 2 and M sub 1. But going to a couple of midpoints, wouldn't those be the congruent corresponding parts? Not only are the sides and angles going to be congruent, but the medians, these would be called medians, and perpendiculars, and all the interior parts would have been the same measure. Now, this is a different kind of a question that we've not seen this year, although it's a really good question. And all of these things, you want to look at them before I talk to you about them. Make a decision, and then come back and look at what I say about them and see if we can agree. So, answer these sometimes, always, never questions before I tell you the answer. You're going to classify them as sometimes true, always true, or never true. I'm going to start right away. If two sides in the included angle of one triangle are congruent to two sides in the included angle of a second triangle, then those two triangles are congruent. Always true. When you have two sides in the included angle congruent to two sides in the included angle, that's really the side angle side theorem, or the side angle side postulate, actually. An equilateral triangle is also equiangular. Yep, sometimes true, always true, or never true. It's always true. If it's equilateral, it must be equiangular. If a triangle is equilateral, then an angle in that triangle may have measure of 70 degrees. And that can't be true. That's never true. Why would that never be true? Because if a triangle is equilateral, we know it's equiangular, and since the angles got to add up to 180, they'd be 60 degrees each. If a triangle is equilateral, then it's equiangular, and all the angles would have measure 60 degrees. The bisector of an angle in a scalene triangle is perpendicular to the third side. That's sometimes true, always true, or never true. Let me make a sketch. If the bisector of an angle is perpendicular to the third side, and let me just show I'll bisect this angle. And say this two angles are congruent, and say that it is perpendicular to the third side. I'm just thinking about this question. Could this be a scalene triangle? Could this triangle be scalene? I say, no, this triangle could not be scalene. Let me label it so we can talk about it. This bisector is perpendicular to the third side, and I hope you would say, well, these two triangles are going to be congruent. They would be congruent by angle side angle matching angle side angle. We should know that right angles are congruent to each other. And if these triangles are congruent, wouldn't this segment have to be congruent to that one? So that triangle would have to be isosceles. So I got to say this is never true. The bisector of an angle in a scalene triangle is perpendicular to the third side. It could not have been scalene. It would have had to have been isosceles. In an isosceles triangle ABC with base AC, the angles A and B are congruent. Now, if the base is AC, with an isosceles triangle ABC, then which angles we expect to be congruent? Not A and B, would have been A and C. So I think the best answer would be sometimes, because had this thing been equilateral, then all three angles would have been congruent. But generally speaking, I say, no, these are not the congruent angles. It would not be angle A congruent with angle B. I think if you said never, I'd say that was okay, but we ought to say sometimes, because the fact is, if it were equilateral, it's also isosceles. If it's got three sides congruent, doesn't it have two sides congruent? So an equilateral triangle was also isosceles, and then all three angles would have been the same. But I say sometimes that's true. Then I hope these next several questions are things that you're familiar with. We got a triangle ABC, and it tells me about angle A, and angle B, and angle C. Write an equation that uses these expressions, find the value of x and the measure of each angle, and then decide if the triangle's isosceles or not. We know by the triangle sum theorem that these things will add up to 180 degrees. Let's write that equation. 10x minus 6 plus 3x plus 50 plus 4x has to add up to 180 degrees. Gathering like terms, I see 17x and a negative 6 and a positive 50. That would be a positive 44 equals 180. Let's subtract that 44 from both sides, and I got 17x equals, and 180 minus 44 would be 100 and, think about that for a second. If I took away 40, that'd be down to 140, so 136. And if I divide both sides by 17, I think it's going to go 8 times. Pretty sure that 8 times 17 is 136. So now I got the value of x. Well, that was part of what I needed to do. I'm going to get the measure of each angle now. Measure angle A. Once we got the equation, it's all downhill, huh? The measure of angle A, 10 times 8 would be 80 minus 6, that'd be 74 degrees, huh? And the measure of angle B, 3 times 8, there's 24, plus 50, oh, that'd be 74 again, huh? Interesting, got a couple of congruent angles. I care about the measure of angle C as well. Angle C is 4 times 8. 4 times x, 4 times 8, that's 32. Now you want to be sure these add up to 180, because if they don't, we made some kind of mistake. I see that those add up to 148 plus 32. Yeah, those are adding up to 180, so I'm happy with that. I don't think we've made any kind of error. But then it asked me, is the triangle isosceles? I say, yes, it must be, because it has a couple of congruent angles. Isosceles triangle theorem is a biconditional. If two angles are congruent, then by golly, two sides are congruent. So I'd say yes, isosceles. Exclamation point. Because angle A is congruent with angle B. Been a while since we looked at one of these questions, but it's a good question type. I'd like to put something like this and something like this on the quiz that you take this week. The interior angles of a triangle are in a ratio of 2 to 3 to 5. Write an equation, find the measures of the interior angles and the measures of each exterior angle. And you're remembering, I hope, that when things are in a ratio of 2 to 3 to 5, we can call them 2x, 3x, and 5x. And since these are the angles of a triangle, we know that they add up to 180. We'll gather like terms pretty quick and easy here. We got 10x equals 180. So x must be 18. So I'm thinking what the angles would be. One would be 2 times 18, there's 36 degrees. One would be 3 times 18, that'd be 54 degrees. And one would be 5 times 18, and that would be 90 degrees. So there's our interior angles. I'm going to make a little sketch of this triangle, quick as I could. Doesn't have to be terribly accurate, but I'll throw in what looks like a 90 in it, probably. And what looks like a 36 and a 54, pretty close. Let's say that this angle was 36. This one's the 90, and there's the 54. I'm going to find the measures of the exterior angles real quick. Exterior angle here. I can subtract 36 from 180, or I can add those two up, but I say that's going to be 144 right there. Extend this side. While I'm at it, I'll go ahead and extend this other one. I'll need to. Extend this side, and that exterior angle would be the sum of the remote interiors, 126. But you can subtract that from 180, so we get 126 there, wouldn't we? And the exterior angle at that 90-degree angle would have been 90, which is the sum of those two. So if I want to list the exterior angles, it would have been 90, 126, and 144 degrees. We've had a little practice with these kinds of questions, where I give you a couple of congruent triangles and information about each of the three sides of triangle ABC. But only you know one thing about the sides of triangle PQR. You know about PR. And what we need to think right away is that PR corresponds with AC by virtue of the way that they're written in this congruent statement. And if PR is equal to AC, that gives us an equation. PR was 3x minus 6. AC was 2x plus 1. We gather like terms, subtract 2x from both sides. I got 1x minus 6 equals to 1. Add 6 to both sides. I got x equal to 7. But notice it asks for the perimeter of triangle PQR. How could I possibly only know one side of triangle PQR? First, let's find the perimeter of triangle ABC. AB, if x is truly 7, would have been 7 plus 2. That would have been 9 plus, and BC would have been 7 plus 5. That would have been 12. Plus, and then AC, 2 times 7, 14 plus 1 would be 15. There's the perimeter of triangle ABC, and that's 21 and 15. I think that's